Hi viewers, in my last video I discussed the percentage change problems with variations less than 5%. In this video I'll be talking about percentage change problems with variations greater than 5%. Before we actually go into the topic, let me recapitulate that if Q is a quantity, delta Q is what is called change in quantity, delta Q by Q is called fractional change, and delta Q by Q into 100 is called percentage change. But you know, delta Q is nothing but Q final minus Q initial. So, delta Q by Q into 100 is equal to Q final minus Q initial by Q initial into 100, which is equal to Q final by Q initial minus 1 into 100. This I'll call it 1, equation 1. Quite surprisingly, what I wrote on the board is neither a formula nor a shortcut, but it's simply the meaning of percentage change. I'll call it a format or a structure which we'll adopt for different formulae from any chapter. Let me make a beginning. Let us take one question. If the length of the simple pendulum increases by 44%, what is the percentage change in time period? This is a question in a competitive examination. Let us say, I'll repeat the question. If the length of the simple pendulum increases by 44%, what is the percentage change in time period? Okay, we'll start. We know that the time period of a simple pendulum is given by 2 pi root L by G. So, in the LHS, I have to calculate the time percentage change in the time period. I'll look at the format. So, I can rewrite it as delta T by T into 100 is equal to, what is the RHS in the format number 1? Q final by Q initial minus 1 into 100. What is the final quantity in the RHS in the given formula? L, which is under power half. So, this can be written as root L final by L initial minus 1 into 100. So, what I did is, I just adopted the format given in equation 1 to the formula in the given question. So, delta T by T into 100 is equal root L final by L initial minus 1 into 100. If L initial will take it as 100, it implies L final is equal to 144, because the question says that the length of the pendulum increases by 44%. Then this implies delta T by T into 100 is equal to root of 144 by 100 minus 1 into 100. What is root 144? 12. Root 100, 10 minus 1 into 100. 12 by 10 is 1.2, minus 1 is 0.2, into 100 is 20%. End of the solution. That means if length of the simple pendulum increases by 44%, it implies that the time period increases by 20%. This is how we'll solve the problem. So, you can understand by now why I asked you to be thorough with the squares and square roots from 11 to 30. Just because I am explaining to you for the first time to have clarity, I wrote so many steps. Otherwise, if you are thorough with squares and square roots from 11 to 30, you can solve this problem in less than half a minute, as you could do with percentage change problems with less than 5% using the shortcut I gave in my last video. So, I have discussed one question now. Now I'll take up the second question or the second example to solve the percentage change problems where the variations are more than 5%. Now let me give you another question. Again, a question given in a competitive examination. Let's say, if the momentum of a body increases by 30%, what is the percentage change in kinetic energy? I am repeating the question. If the momentum of a body increases by 30%, what is the percentage change in kinetic energy? Okay, we'll start. We know that kinetic energy Ek is equal to P squared by 2m, where P is the momentum. Let us look at the format one. LHS, delta Q by Q into 100. In this relation, delta Ek by Ek into 100 is equal to, what is the RHS in format 1? Final quantity by initial quantity minus 1 into 100. What is the final quantity in the given relation? Momentum. In the RHS, what is its power? 2. So I can write it as P final by P initial whole square minus 1 into 100. The question says the momentum increases by 30%. So if P initial is equal to 30, it implies P final is equal to 130. So we'll substitute this in the above expression. Implies delta Ek by Ek into 100 is equal to P final 130 by P initial 100 whole square minus 1 into 100. You know these two zeros get cancelled. 13 squared is 169 by 10 squared is 100 minus 1 into 100. Now 169 by 100 is 1.69 minus 1 is 0.69 into 100 is 69%. End of the solution. So summary of the discussion is, if momentum P of a body increases by 30%, it implies that the kinetic energy Ek increases by 69%. So this is how we can adopt the format or the structure given in equation 1 to any relation in any chapter and solve the problems of percentage changes where the variations are greater than 5%. These are all very simple methods, and as I told you, for this, if you have the squares and square roots from 11 to 30, you should not take more than half a minute to solve the bit, and the mark is yours. Well, I'll discuss the percentage change problems with quantities related inversely in a given formula in my next one.